We have a 14 microfarad capacitor. We connect it to an EMF source of 120 volts and we charge the capacitor. Then we disconnect it from the EMF source and we connect it in series with an inductor of inductance 0.24 millihenry. Now we have an LC circuit with the capacitor fully charged at the beginning. The first question is, what is the oscillation frequency of this LC circuit? The angular frequency of the LC circuit is related to its physical properties, namely the inductance and capacitance. And the angular frequency omega is equal to 1 over square root of L times C. Now the frequency is angular frequency divided by 2 pi. Let's combine these two formulas to come up with an expression for frequency f. F is equal to 1 over 2 pi square root of L times C. Substituting the numerical values for L and C, we get frequency equals 2.7 kilohertz. Meaning in 1 second, the circuit will complete 2700 full oscillations. And one oscillation will be discharging of the capacitor, charging in the opposite direction, discharging again, and going back to its initial charged state. The next question is, what is the energy stored in the capacitor at t equals 0 seconds? At t equals 0 seconds, the capacitor has just been connected with the inductor, and before that it had been fully charged while connected to the EMF source. So at t equals 0 seconds, the potential difference between the terminals of the capacitor is equal to the EMF voltage, which is 120 volts. Since we also know the capacitance of the capacitor, we can use the formula 1/2 CV squared to calculate the energy stored in the capacitor at t equals 0 seconds. Keeping two significant figures, we get 0.10 joules for the energy stored in the capacitor at t equals 0. Finally, let's calculate the energy stored in the inductor at t equals 1.20 milliseconds. The energy stored in the inductor as a function of time is equal to 1/2 Li squared, where we're using lowercase I for the current because current changes with time. Here I have substituted the time-dependent formula for current in an LC circuit. Current is equal to negative omega q times sine omega t. Again, omega is the angular frequency of our LC circuit, and capital Q is the initial charge accumulated in the capacitor. That's the charge that was on the capacitor when it was fully charged by the 120 volt EMF source. So let's actually go ahead and calculate the numerical values for omega and capital Q, and then calculate the energy stored in the inductor. Angular frequency is equal to 1 over square root of L times C. Keeping three significant figures, since this is an intermediate calculation, we get 1.73 times 10 to the 4th radians per second. Initial charge on the capacitor is equal to its capacitance times its initial potential difference. Keeping three significant figures, that's equal to 1.68 times 10 to negative 3rd coulombs. Now let's go back to our energy calculation. After the numerical substitution, keeping two significant figures, we get 0.090 joules of energy stored in the inductor.